In our last lecture, we talked about what meteorology was and what it wasn't, and I ended by talking a little bit about weather versus climate. And so that's what we're going to jump into now, talking more about the differences between the two. And if you're like me, you've probably heard these two terms almost interchangeably. Climate control, like the temperature inside your house or the temperature inside your car. Or what's the climate in the room? When talking about weather, what's the weather going to be like in the next week? Or what's the climate going to be like in the next week? And these two terms are often used interchangeably. And yet, they're two very different terms. And so, one of the goals for this class today is going to be to differentiate the two. Differentiate weather versus climate. And then to give some examples of each. So let's jump in. So first off, what is weather? Well, weather is simply talking about the atmosphere. Weather is simply talking about the atmosphere. Particularly, it's talking about the condition of the atmosphere at a given place and a given time. Now, most people, when they hear the word weather, they think about temperature. Well, do me a favor, write it in red if you have to. Weather and temperature are two different things. Weather is not just temperature. Weather actually consists of numerous conditions. And when we talk about the overall condition of the atmosphere, we're talking about things like temperature, pressure, humidity, cloud cover, and so on. So not just temperature. So if you say something on an assignment like, the weather has gone up, or the weather has gone down, that's incorrect. What you're meaning to say is that the temperature has gone up, or the temperature has gone down. So make sure to really watch out for that throughout this quarter. When we're talking about weather, we're talking about everything that's happening in the atmosphere. Temperature is just one component of it. Weather is also referred to as the here and now of the atmosphere. And the reason why this is important is that weather can vary greatly over a small area. So for example, I'm recording this video right now in Cupertino, California. That's in Silicon Valley, west of San Jose. I can assure you right now, the temperature and the overall weather conditions here in Cupertino are different than they are in San Jose, or they are in Mountain View, or they are in Sunnyvale. And don't believe me, if you actually look at a temperature map, you can actually see variations in that one variable from place to place. And you would see the same thing in humidity, dew point, or even cloud cover. So weather can vary greatly over a small area. The other thing that weather can do is it can also vary greatly over a short period of time. So if you've ever heard of the phrase, if you don't like the weather, wait 5 minutes, well, it's actually kind of true. The weather currently outside right now is constantly changing. And those changes are usually very slight, very subtle, but it's happening. So going back to temperature, we can actually say that, well, the temperature outside now is different than it was 5 minutes ago, and it's different than it will be 5 minutes from now. And that's actually probably true. Of course, again, the differences aren't great, but they happen. And so overall, when we talk about weather, we're talking about the conditions right here, right now. They're different from place to place, and they're different from moment to moment. And the cause of differences in weather are the sun. And we'll actually talk more about why that is next module when we talk about heating the earth. But yeah, weather varies from place to place. So this is a temperature map. I actually pulled this temperature map up a few months ago, but it demonstrates this. Here I am over near De Anza College in Cupertino, and the current temperature where I'm located is 55 degrees. I have a wind coming from the southeast at 5 knots. And then as you go just a little further away over near where the Apple campus is, they have a calmer wind and a temperature of 56. Or if you go up towards Sunnyvale, that area, there are a lot of 57s. Go over to downtown San Jose, 56, 57, the airport's reporting 57. But again, the idea here is just that weather varies from place to place. These conditions, whether it's wind speed, wind direction, cloud cover, air temperature, they vary from place to place. And then if we instead wanted to look at one place and look at how weather changes, we can actually notice that weather also changes from minute to minute. So this graph right here is a graph that I took from the National Weather Service. And they're sort of the head honchos when it comes to meteorology, and they manage weather stations all across the country. And this I took from San Jose International Airport, and it's showing you 3 different weather conditions. The blue line here represents air temperature, the green line here represents relative humidity, and the black line represents dew point temperature. And if you actually take a look, these don't stay constant. Rather, they are always changing, minute from minute, hour from hour. There's a noticeable change from one moment to another. And so that's a crucial component of weather. Weather is constantly changing. So I've already kind of hinted at this, but what are some of the weather conditions that we talk about? As I had mentioned, usually the one people talk about the most is air temperature. And it's because it's essential to human comfort. It greatly determines what you're going to wear that day. If the air temperature outside is 30 degrees, you're probably going to wear a heavy jacket and boots and layer up. On the other hand, if the temperature outside is 90 degrees, you're probably going to wear shorts and a short sleeve t-shirt and try to dress a lot more for warmer weather. And so air temperature is often seen as that most important variable, but it's not the only one we care about. Other things we care about, air pressure, and we'll talk about that a little bit in our next lecture, or actually in 2 lectures. Cloud cover, so how many clouds are there outside? Is it sunny? Is it cloudy? Precipitation, is there stuff coming out of the sky? Is it raining? Is it snowing? How bad is it raining? How much is it snowing? We care about that. Humidity, relatively subtle, but has a big impact. Don't believe me? Spend a summer day in the deep south, and humidity plays a big role on comfort there. Wind direction and wind speed. We'll talk about this a little bit later in this module. And visibility. If you've ever driven in a really heavy fog, and you've been more stressed out because of that, we care a lot about visibility as well. And this is just a taste of some of the different weather conditions we care about. And these weather conditions are often interconnected. For example, visibility may be low if it's foggy, and that usually happens when humidity is high and air temperature is low. So that's just one example of how these can be interconnected. Or another one, the type of precipitation falling from the sky is greatly dependent on the air temperature. If the air temperature is above freezing, you get rain. If it's below freezing, you get snow. So as a result of each of these weather conditions really playing an important impact, we actually want to be able to measure them. We want to be able to figure out, okay, well, how hot is it outside? Or how cloudy is it outside? Or how windy is it outside? And while a qualitative assessment might be good enough for me and you, it's hot outside, it's cold outside. For a scientist, they want numbers. And as a result, they actually want to be able to measure these weather conditions. And there are numerous ways we can do this. And these are what are called platforms. A platform is essentially something that we place a weather instrument on. And there are numerous types of platforms, such as ground instruments. So this is an instrument that is put on a pole that is planted into the surface of the earth. Many weather stations are ground stations like this. But if you wanted to get an overarching view of weather conditions, you wouldn't want to look at just one ground station, you'd want a bigger picture. To do that, we can use satellites that are orbiting our planet. If we want to take a look at weather conditions above the surface of the Earth, which is actually very important, and we'll uncover why more throughout this course, we'd want to launch weather balloons. Another thing we may want to do is take a look at where it's raining and where it's not raining. Well, we could call a bunch of weather stations and they can tell us if it's raining or not, but since we don't have an infinite number of weather stations and an infinite number of staff to report conditions, another easy way to tell is using what's called weather radar. And basically this is an instrument that's put on a mountaintop, the instrument rotates, and as the instrument rotates, it sends out a pulse. That pulse is then reflected and heads back to the station, and the nature of that reflection tells us if there's rain or not, or if it's snowing, or what kind of precipitation. Other platforms, you can actually have portable platforms, such as a weather station put on a moving vehicle, or a pocket weather station. So there's so many different platforms that we can use to mount weather instruments. So here are some ground instruments. Again, these are instruments that are planted in the ground, they stay there, they're not moved. Here is a satellite image, and again with satellites, you have this sensor in space essentially taking a picture through one of various ways of weather systems on the Earth. And so one of the things we look at are cloud cover. And as you can tell from this particular image, there's a big weather system right here. A big weather system that could be identified by this organized area of clouds. Here's a radar image. And so the way that a radar image works, if I can get my little pen out, here, let me use light blue. So let's say we have a station right there, a radar station. The radar station will send a pulse into this rain. Then the pulse will actually hit these raindrops, bounce back out, and return to the station. And then the nature of that return, such as how long did it take to return, how much of it returned, and so on, can then tell us a lot about, okay, is there precipitation, how much precipitation is falling, and what kind of precipitation it is. And this is important because we want to know where it's raining and where it's not. For example, if you live in Greene County here, and you see all this rain to your west, well, you can actually view a time lapse of this and see how this system is moving. If this rain is moving in a west to east pattern, the people in Greene County can expect rain soon. On the other hand, if all of this rain was moving to the west, then if you're in Greene County, then you could say, okay, well, the worst is over. The rain's gone, all is well. So we really care about this because it tells us where it's raining and how heavy the rain is. Here's a weather balloon. And this is yours truly right here with one hand on it. And this gentleman over here with the other hand, his name is Jeff Forgeron. He's actually an on-air weather broadcaster. So yes, even though I said there are more career opportunities than that, some people do go into that. And Jeff is one of those people. He's an on-air weather broadcaster in Waco, Texas, and a really cool guy. So if you're ever in Waco and you watch the news, That's Jeff. And we were doing a research project that involved launching a weather balloon. And so here's me holding on to it, and there he is. And attached to this weather balloon is an instrument pack called a radiosonde. And what a radiosonde does is, as you rise up in the atmosphere, this radiosonde measures different weather conditions. So it measures air temperature, it measures wind speed, it measures dew point temperature, wind direction. And each of these things actually give us a really good idea of how weather conditions are changing as you rise in the atmosphere. Now, why would we care about that? Well, we care about it for a couple of reasons. One, the temperature of the air higher up actually determines what's called stability. And if the temperature high up is very, very cold, then air from below can actually rise, and that could create thunderstorms. On the other hand, if the temperature higher up is relatively warm, then air from below can't rise. And so if you've ever seen one of those days, and actually I can even see it in this picture back here behind me, where you have that gray, dirty layer near the ground, that's because of what's called an inversion. Air higher up is warm, and so this air down here can't rise. There are other things we look at: convergence, divergence, the location of what's called a jet stream. And each of these things have major implications on the formation of large-scale weather systems, on severe weather outbreaks, so tornadoes, on where hurricanes go. So we really do want to understand weather in the upper atmosphere. So yeah, we are definitely using weather balloons. Here are some of the portable weather instruments I was talking about. This one right here is an instrument that I have called a Kestrel. It's just a pocket weather instrument, and it can be used for making weather conditions or measuring weather conditions anywhere that you want to go to. And so if you're like me and you want to know what the temperature is at any location, you can use that and it'll tell you. A much larger, not pocket instrument, but still portable, over here is what's called a Doppler on wheels. And a Doppler on wheels is something that can be used to actually go and monitor where there's rotation in the atmosphere. Basically, it's like a miniature radar. And in addition to telling us where precipitation is, radars can also tell us where rotation is. And areas of small rotation typically mean tornadoes. And so that's what this is here. This is basically a tornado chasing instrument. So pretty cool stuff. So that overall tells us about weather. Weather is the condition here and now. Weather conditions are measured using all these different instruments, using various platforms. But what about climate? So, as I said at the beginning of this lecture, weather and climate are often used interchangeably, when in fact, they're very different. So let's talk about it. Climate actually represents the average weather of a given region. So think about where you're watching this video at right now. And think about what the weather's like outside right now. Is it normal? So for example, is today a much warmer than normal day? The day that I'm recording this video, it is a much warmer than normal day. Is it a much colder than normal day? Is it a much wetter than normal day? Is it a much drier than normal day? Well, those things actually define a location's climate. Basically, climate tells us the normal, the average weather of a given region. Whereas weather deals with the instantaneous condition, meaning the condition right here, right now. It changes a second from now, it changed from a second ago. Climate, on the other hand, is an average. Basically, we take average weather conditions for a region over a long period of time, and that then tells us, okay, this is what you expect. You expect rain in the winter, dry in the summer. Cold in the winter, hot in the summer. And if you actually think about this, this can greatly dictate culture in a sense that if you live in a location where it rains in the winter, then people's plans usually change in winter months. They do things that are more indoors. Or you start to see umbrellas suddenly come on sale. You don't see that as much in the summertime. Or you see heavier coats come on sale in the wintertime. And then the shorts, the t-shirts, the bathing suits, those come on sale in the summertime. Well, that's all because of a location's climate. And a location's climate also takes extreme weather events into account. And in fact, these can even be used to distinguish two locations with similar climates. For example, if you think about California, Southern California in particular, the temperature in Southern California is usually pretty warm in the summertime. You get temperatures in the mid to high 80s in a lot of regions. Well, the east coast of the United States is very similar. You also get very similar temperatures in the summertime. The difference is California doesn't get hurricanes. The east coast of the United States does. And so we can actually use the occurrence of extreme weather events to also partially define a location's climate. For another example, states like Oklahoma, Kansas, and Texas get a lot of tornadoes. States like Oregon and Washington don't. P.S. Don't mind the bloopers. Over time, I will get better with them, but still, Oregon and Washington don't get tornadoes compared to a place like Texas or Oklahoma, which do get tornadoes. And so when talking about a region's climate, we're talking about the typical weather conditions, what you typically get, what you normally get. And as I just mentioned, tornadoes are common in Texas, not so much in California. And the occurrence of extreme events can help distinguish between two otherwise very similar climates. But yeah, climate is, again, overall, the average conditions. Now, with that said, when you take an average of something, like let's say I take the average of this class on a test, and let's say I've got 50 students, and from those 50 students, the class average is 80%. Then I get a 51st student who comes in. Regardless of what their test score is, their test score could be 0, their test score could be 100, the overall average based on 50 students probably isn't going to change much. And it would take a lot of extra students getting extreme scores to really impact the average. So when we talk about climate, climate changes over a much slower time period than weather. Weather can change from minute to minute. Climate takes a long time to change. And so yeah, climate essentially defines what's normal. What regions are really wet, what regions are really dry, what regions are really hot, what regions are really cold. And so when talking about climate, that's essentially what we're talking about. What's normal? So how do we compare the two? Well, weather represents short term, and it also represents at a given location, whereas climate deals more regionally, so over a larger area, such as I said a few minutes ago that the weather conditions here in Cupertino are different than the weather conditions in, say, San Jose. Well, the climate between the two isn't really different. We both have similar temperature patterns, we both have similar precipitation patterns. They're not really different. So climate changes take a larger area to really experience a noticeable change. Like going, instead of from here to San Jose, going from here to Santa Cruz, on the other side of the Santa Cruz Mountains. There you'll experience a different climate because the mountains cause some things to happen, and we'll talk about those later this quarter as well. So weather talks about short-term changes, climate talks about long-term averages. Weather talks about what's going on right now. Climate usually tells us what to expect. Weather changes happen very instantaneously. Climate takes a really long time to change. And then weather varies greatly from place to place. Climate, much more over a larger region. So here's some examples of weather versus climate. A few examples I would give. Currently outside, the temperature is 85 degrees. That would be the weather. On the other hand, climate would be, well, the average temperature today, so what's normal, is 65. And so we can actually use climate to then define, is the weather we're experiencing normal or abnormal? Or it rained a lot today. That could be weather. Climate, on the other hand, would be, well, it normally doesn't rain that much. So that's the difference between weather and climate. So just to review, weather is the state of the atmosphere at one place, at one moment, in one location. And we measure weather conditions using various platforms. On the other hand, climate is the average state over a given region. One thing I should say about climate is, in order to really understand a location's climate, we have to measure it. And the way we measure a location's climate is the exact same way that we measure weather. The only difference is, rather than looking at one data point, what the weather's like at one given time, we look at how the weather's like over a large period of time. But that's really the big difference between measuring weather and measuring climate. Now for the next lecture, in this lecture I talked a lot about the state of the atmosphere, here and now, given place and time. Well, for the next two lectures, I'm going to cover a lot about the atmosphere itself, what the atmosphere is, what it's made of, and that will present a little bit more of a context of weather. So until then, I'm Terrence Mullins. Thank you for watching.